right, so today in the A3 notes, we're going to be looking at geometry, area, and perimeter. We start out with a reminder with the formulas for perimeter and area. In the first example, a rectangular field has a perimeter of 500 meters. Its length is 3 times its width. So it might help us to start off on this question by drawing a picture. The length is 3 times its width. So the width, let's say we don't know that, so that's x, and then the length is 3 times that, so 3x. The question says that the perimeter is 500 meters. So I can start by applying the formula for perimeter. So the 4 sides all added up to one another would equal 500, and then I can solve for x. Combining like terms would give me 8x equals 500, and then I would finish by dividing both sides by 8, and that'll give me x is equal to 62.5. Once I have x, I can substitute x in for both the width and the length to figure out the 2 dimensions. And so the width is just x, so the width is 62.5 meters. And then to get the length, I'm going to do 3 times 62.5, and that gives me 187.5 meters. So those are 2 of the answers to the question. The third part of the question asks us to figure out the area of the field, and so you'll want to remember that area is length times width. And so I'll do the 187.5 times 62.5, and that gives me 11,718.75 meters squared. Here's a reminder about some of the formulas that we use when we're calculating volume. Volume is a measure of the 3-dimensional space inside a shape. And so in the first example here, we're going to find the volume of this sphere. The radius is given to us, so we're just going to plug radius into the formula. So from the provided formulas, volume is equal to 4/3 pi r cubed. And so I'll plug the 3 in for r. 3 to the third gives me 27. 27 divided by 3 gives me 9. And then 4 times 9 gives me 36. So I could write the answer as 36 pi feet cubed. Remember, with volume, the units are always going to be measured as cubic units. Sometimes it wants you to find the exact answer, and so you would times 36 times pi. And so for this one, I would get 113.1 cubic feet rounded. In the next example, you need to find the volume of this cylinder, and so you'll use the cylinder formula from up above. So I'll plug in 5 for my radius, and then I'll plug in 12 for my height. 5 squared gives me 25, and then 25 times 12 gives me 300 pi centimeters cubed. Again, if you want the answer left in pi, you would write it like this, or if you wanted to find a rounded answer, it would be 942.48 centimeters cubed. And so again, I'm getting that answer just by multiplying the 300 times the pi button on a calculator. On the next example, there's just a mistake. Change the square to be to the 3rd power. So what is the height of a cone if the volume is 297 pi centimeters cubed and the length of the radius is 9 centimeters? So this one's a little bit different because you have to work backwards. The formula for the volume of a cone is volume equals 1/3 pi r squared h. And so this one's a little bit different because you need to plug the numbers in that you have, but you're going to be solving for a different number. Here, let me make this a little bit larger so it's easier to see it on your screen. 297 pi goes in for the volume. 1/3 pi. The radius is 9 squared, and then the h is what you're solving for. So the h is the part that you don't know. So when you're solving on this one, you can simplify over here on the right a little bit, but then you're going to be dividing by whatever you get there because you're trying to get the h all by itself. So let's see, 9 squared gives you 81. 81 divided by 3 gives you 27. So 297 pi is equal to 27 pi times the height. And then remember, I'm trying to solve for height, so I'm going to divide both sides by 27 pi because that would make the 27 pi cross out. So these would cross out, and then over here the pi's would cross out, and 297 divided by 27 gives you 11. So for this one, you get that the height of the cone is 11 centimeters. All right, moving on to the next example. So the formula for the equation of a circle is defined as being the set of all points that are a fixed distance from a center. The formula for the equation of a circle is given here as well. The number next to the x is the x coordinate of the center of the circle. The number next to the y is the y coordinate of the center of a circle. And then the radius is the square root of the number that comes on the other side. See how on the h and on the k there's negatives next to them? That means that when you're writing the formula for the equation of a circle, it's always going to be the opposite sign from what you see on the equation that gives you the center. So in the first example, I'm writing the equation of a circle with a center at 3, 4 and a radius of 6. So it's going to be x minus 3 squared plus y minus 4 squared. The signs on the 3 and the 4 are always going to be opposite what they start out as when you plug them into the formula. Is equal to, and then it's not equal to 6, it's equal to 36 because you square the radius. Here on the next one, we're just doing the backwards. So we're given the equation of a circle, and they want us for this one to figure out what the coordinates of the center of the circle is. And so the xy coordinates for the center of the circle, it's going to be -4, +2. Because remember, it's the opposite sign that you see. So right here where you see a +4, it turns into -4. And then here where you see a -2, it turns into +2. And then the last circle question asks me to figure out the radius of a circle. And so for this one, I'm not trying to figure out the coordinates of the center. I'm trying to figure out the length of the radius. And so remember, the radius is given by the number that comes after the equal sign, and it's always the square root of that number. So for this one, your radius would be 8 because the square root of 64 is 8. All right, up next, perpendicular bisector. The perpendicular bisector of a segment is a line segment that is both perpendicular to and passes through the midpoint of the segment. And so in this picture over here, I'll highlight it in green. This line M that I just highlighted in green, that's the perpendicular bisector. It's perpendicular to AB, you know that because of the box in the corner. And then it's a bisector because it cuts segment AB in half, and you know that because of the two little markings here and here. Those show you that those are congruent to one another. So perpendicular bisector is both perpendicular and cuts it in half. So here in the next example, segment DB is the perpendicular bisector of segment AC. Use the diagram to answer the following questions. And so on this picture, segment DB is the perpendicular bisector. The first question asks which segments above are congruent. And so the first two that you see are the two that have the markings on them, right? So segment AE is congruent to segment EC. Because segment DB is the perpendicular bisector, it cuts it in half. So each of those two sides are equal to each other. We know that because of the markings that are on the picture. There's also two other segments on this picture that are congruent to one another. Because of the perpendicular bisector theorem, we know that segment AD is congruent to segment DC. That's not marked on the picture, but you can add markings on the picture. So the perpendicular bisector theorem tells us that that's true. And then also we know that segment AB is congruent to segment BC. So down here, we know that these two segments are also congruent to each other. And again, that's by the perpendicular bisector theorem as well. The last part of this question asks which segments are perpendicular. And so looking back up at the picture, segment DB is the perpendicular bisector. It cuts segment AC in half, and it's also perpendicular to that segment. And you can tell that by this little 90-degree box that's right here on the picture. And so the two segments that are perpendicular to each other in this picture are segment DB, that's the perpendicular bisector, and segment AC, that's the segment that gets cut in half. This little symbol right here is a symbol for perpendicular. For angle pair relationships, angles that are vertical angles are formed by two pairs of opposite rays. Vertical angles are always congruent. And so in the first example, these two angles that are given to you here are vertical angles because they're across from one another on an x. And so by the vertical angles congruence theorem, we know they're congruent to one another. So if I'm going to solve for x, I'm going to set those two expressions equal to one another, and I'll solve for x. So 3x minus 40 is equal to 2x minus 10, and then I'll solve for x. So I minus the 2x from both sides and then add 40. And so the first answer I get to this question is that x is equal to 30. Now I need to find the measure of each labeled angle. So I'm going to take the 30 and I'm going to plug it into both sides. So 60 minus 10 is 50 degrees. And when I plug it in on the other side, I'm expecting I'm also going to get 50 because the vertical angles should be congruent to one another. So 90 minus 40, and 90 minus 40 does in fact give me 50. So those are my other two answers to the question. The next definition that's provided to us is the definition of linear pair. So a linear pair is a set of two adjacent angles that are formed when two lines intersect. Angles that form a linear pair are always supplementary. And so in this picture, notice that the two angles that are formed to make a straight line, angles that add up to a straight line are always 180 degrees. They're supplementary to one another. And so to solve for x on this one, I'm going to sum the two angles and set them equal to 180. So 9x plus 2 plus 3x plus 10 is equal to 180, and then I'll solve for x. So I'll combine like terms. I'll subtract the 12 from both sides, and then I'll finish by dividing both sides by 12. And so for this one, I get x is equal to 14. Remember that that's only part of the answer to the question, however, because you're also being asked to find the measure of each of the labeled angles. So once I have x equal to 14, I'm going to plug that into both of the two expressions. And so 42 plus 10 gives me 52 degrees. So this angle here is 52 degrees. Now, when I plug the 14 into the other part of the angle, I'm not expecting to get 52 as my answer to the question. I should get 128 because the two numbers that I get as answers should add up to 180 degrees. So it's a nice way to check your answer. 9 times 14 is 126, and then 126 plus 2 does in fact give you 128 degrees. So the two angle measures are 128 degrees and 52 degrees. And you can check them by making sure that the two angles add up to equal 180, and they do. All right, so next up, you're reminded about some of the named angle pairs. So you have corresponding angles, you have alternate interior angles, you have alternate exterior angles, and then you also have same side or consecutive interior angles. And so the angle pairs are listed off for you. This part down here is also important as well. It says when the lines are parallel to one another, the alternate interior, alternate exterior, and corresponding angle pairs are congruent, and the same side angle pairs are supplementary to one another. And so that fact will be important because we'll use that to solve problems involving these angle pairs. So here in this next example, it says, given that the lines are parallel, solve for x. So looking at the first one, these two angles are on opposite sides of the transversal, and they are inside the parallel line. So these are alternate interior angles, and from the definitions that we just looked over before, when the lines are parallel, the alternate interior angles are congruent to one another. So to solve for x on this one, I'm going to set 6x plus 42 equal to 18x minus 12. And then I'll solve for x. So I'll minus the 6x from both sides, and then add the 12 to both sides. And then I'll finish by dividing both sides by 12. And so on this question, I'm going to get that x is equal to 4.5 when I perform that division. On the next question, the two angles are on the same side of the transversal and also inside the parallel lines. So these are same side interior angles, also called consecutive interior angles. These angles are not congruent to one another. These angles are supplementary. They add up to equal 180 degrees. And so to solve for x on this one, I'm going to do x plus 75 plus x plus 125 is equal to 180. And then I'll solve for x. So I'll combine like terms. I'll subtract the 200 from both sides. And then I'll finish by dividing both sides by 2. So for this one, I'm going to get x is equal to negative 10. Remember that you can't get an angle measurement that's equal to 0 in this type of problem, but you can get a value for x that's a negative number. If I plugged negative 10 in, it wouldn't create a negative angle on either spot, so I know negative 10 is an okay answer. All right, next up is the Pythagorean theorem and its converse. So the Pythagorean theorem is a squared plus b squared equals c squared, and so we can use the Pythagorean theorem to calculate the length of a missing side. On this right triangle, the two lengths that are given are both the legs of the right triangle, and the x is the hypotenuse. Remember, it doesn't matter whether the 6 goes in for the a or the b, the 2 square root of 3 can go in for the a or for the b, but the x has to go in for the c because the x is the hypotenuse. It's the side of the triangle that's opposite the right angle. So I'll plug in my values, and then I'm going to simplify by squaring. 6 is 36. When I square 2 square root of 3, you're multiplying 2 square root 3 times 2 square root 3. So 2 times 2 gives you 4. And then the square root of 3 times the square root of 3 gives you the square root of 9, which turns into just 3. So let's see, 36 plus 12 is equal to x squared, and then combine like terms. So I'll get 48 is equal to x squared. Remember, you're trying to solve for x, so now you're going to take the square root of both sides. And then here's where you'll pause because the directions to the question said to write your answer in simplest radical form if necessary. So 48 as a square root is not a perfect square, but it has perfect square roots that are hiding inside of it. 48, let's see, we can break it down. 48 is 12 times 4, and so the 4 comes out as a 2, but then 12 is 4 times 3, and this 4 also comes out as a 2. So I can take out a 2, I can take out a 2, and you multiply those together. So you took out a 4, and then you still had a 3 stuck inside, and so the 3 stays inside the square root. And so the missing side on this right triangle is 4 square root 3. And so on the converse of the Pythagorean theorem, the problems are going to look a little bit different. Looking here at this first example, so you're given all three sides. One side is 4, one side is 4, one side is 4 times the square root of 2. Use the converse of the Pythagorean theorem to prove that the given side lengths could form a right triangle. And so you're trying to see if a squared plus b squared equals c squared is true. So you're trying to show, does a squared plus b squared equal c squared? It's a question. So I'm going to start by plugging in my numbers. Remember, the biggest number has to go in for c, but then either of the other two numbers can go in for a or b. So 16 plus 16 is equal to, when you square 4 square root 2, you're doing 4 square root 2 times 4 square root 2. So 4 times 4 gives me 16, and then the square root of 2 times the square root of 2 gives me the square root of 4, and the square root of 4 is 2. 16 plus 16 gives me 32, and 16 times 2 gives me 32, and so this is in fact correct. You're trying to prove that the given side lengths could form a right triangle, and so the answer is yes, they could form a right triangle. In this next example, we're trying to use the converse of the Pythagorean theorem to prove that the side lengths could not form a right triangle. So we're going to do the same thing. Remember, a and b can go in for either number, but c has to be the biggest number. So in this problem, I'm going to be putting the 8 in for c because 8 is the largest number. So I'll start by plugging in my three values, and then I'll simplify by squaring each one. So 25, 49, and 64. And then I'll simplify on the left-hand side. 25 plus 49 gives me 74, and 74 is not equal to 64. And so the answer that you would write down for this question is no, the side lengths could not form a right triangle. All right, moving on. So a translation is a function that moves an object a certain distance. The object is not altered in any way. It's not rotated, reflected, or resized. In this motion rule that's given to you here, it says that each coordinate is going to be moved so that the x's go +2 and the y's go +3. So you want to remember which axis is which. Remember that the x-axis goes from right to left and then the y-axis goes from top to bottom. So if the x's are being increased by 2, that's going to move that point 2 to the right. And then if the y's are being increased by 3, that's going to move the point up 3. So you're just describing the direction that the shape is moving. Remember, it's not getting any bigger, it's not getting flipped around, it's just sliding 2 to the right and up 3. In the next example, we're given the coordinates for a point and we're being asked to figure out what the new coordinates would be after it's moved according to the given motion rule. So the x's are going to go up by 3, so I'll add 3 to the x coordinate, and then the y's are going to go down by 1, so I'll subtract 1 from the y coordinate. The image of the object after the translation is given as a prime, and so 4 plus 3 gives you 7, so the new x coordinate would be at 7, and then -2 take away 1 gives you -3, so the new y coordinate would be at -3. So 7 comma -3 would be the image of the point after the given motion rule was applied. All right, so on this next example, you're given the coordinates of a triangle, EFG, so you start off by plotting those. And so here's my original triangle EFG with the given coordinates. And we're trying to name the new coordinates of triangle E prime, F prime, G prime if it's translated according to the motion rule. And so on the motion rule, the x's are being increased by 4 and the y's are being decreased by 2. So there's a couple of different ways you can do it. You can do it based off of the picture since you have the graph. That's how I'm going to do it. But you can also use the +4 and -2 on each of the coordinates of the points. So each of these points is going to move 4 to the right and then down 2. The whole triangle is going to move 4 to the right and down 2. But I like to move each of the vertices of the triangle separately. So I'll start with E. So E is going to go 1, 2, 3, 4 to the right, and then it's going to go down 1, 2. And so the new coordinates for E prime are going to be at the point 1, 2. I'll do the same thing now with F. So F's going to move 1, 2, 3, 4 to the right, and then it's going to move down 1, 2. So the new coordinates for F prime are going to be at the point -1, 3. And then lastly, I'll move G. So 1, 2, 3, 4 to the right, and then down 2. And so the new coordinates for G prime are going to be at the point 1, -2. And so your new triangle on the graph, the image is going to be located here on the graph. Notice that the two triangles are the same shape, the same size, the same direction. It's just the new one has slid to the right and down based off of the motion rule. All right, the notes today finish with a review of some different geometric shapes. So the first one is an isosceles trapezoid. A trapezoid is a type of quadrilateral. So it has 4 sides. It is not a parallelogram. And so that's why we're doing this one first. Isosceles trapezoids have 5 different properties. So exactly one pair of opposite sides is parallel. Each pair of lower and upper base angles is congruent. So those 2 angles are congruent and these 2 angles are congruent. The non-parallel sides, which are called the legs, are congruent. The diagonals are congruent. Diagonals connect the non-consecutive vertices, and so the diagonals that I just drew in red are congruent to one another. And then the lower base angles and upper base angles are supplementary. And so if you add up the angles that are not congruent to one another, they add up to equal 180 degrees. Parallelograms are also a type of quadrilateral, but they have a different set of properties about them. Both pairs of opposite sides are parallel. Next, both pairs of opposite sides are also congruent. Both pairs of opposite angles are congruent. So these 2 angles are equal, and then these 2 angles are also equal. Both pairs of consecutive angles are supplementary. So all of the different pairs of angles that are next to one another around the whole shape add up to equal 180 degrees. And then lastly, the diagonals bisect each other. So on this picture, the 2 lines that I just drew in red, they're not equal to one another, but they each cut each other in half. Rectangles are a type of parallelogram. In addition to the 5 properties of parallelograms that we listed up above, rectangles have 2 other things that are true about them. All 4 angles are right angles, and then in addition to bisecting each other, the diagonals are also congruent. Rhombuses are another type of parallelogram. In addition to the 5 properties of parallelograms that we described up above, rhombuses have a few other things about them that are true. All 4 sides are congruent. The diagonals not only bisect each other, but are also perpendicular. And lastly, the diagonals bisect both pairs of opposite angles. These properties are true in addition to the 5 properties of parallelograms that are outlined up above. And lastly, squares. So squares are another type of parallelogram. Squares are a rhombus and a rectangle married together. And so the list of 5 properties that are here, F through J for squares, are the 2 properties for rectangles and the 3 properties for rhombuses combined together. So squares have it all. So all 4 angles are right angles. The diagonals not only bisect each other, but are also congruent. All 4 sides of the shape are congruent. The diagonals are perpendicular. And lastly, the diagonals bisect both pairs of opposite angles.